Okay, this is 6-2, systems of equations and 3 variables. So, one type of equation that we might be given would be maybe x minus 2y plus 3z equals 11, and 4x plus 2y minus 3z equals 4. And then we're going to have a third equation, 3x plus 3y minus z equals 4. What this represents, and usually your equal signs are all basically lined up with each other just to keep it in nice orders. Your z's and your y's are all in a row. We've always in the past had equations that would just look like y equals maybe like 2x plus 3. And we're adding in the z when we get into more like three-dimensional things. Maybe if you guys ever take Calc 3, you get like z equals 2y plus 3x plus 5. What this really represents is, excuse me, is a function in 3 dimensions, because things are not always just really nice and pretty, and they don't just always go straight up or down or whatever. They don't just do that in 2 dimensions. What also happens is we're going to start adding this third dimension, and we're not going to be asked to graph it because that's still crazy. And we've added a third dimension, so now like z would be going up and down. I have y and x. Okay, so maybe if I went like a couple rows and whatnot, you know, we would have some function that's like going crazy. We can't really tell what's happening. Okay. On a two-dimensional picture, you really have no idea what's happening, and this is really a terrible picture. But this is the basics of what's happening in 3 dimensions. However, 3 dimensions are not always, they're not always talking about X, Y, Z. It could be just like the problems that we had, like we have caramel corn and nuts. Oh, now we're going to have some dried cranberries into our mix. That could also be what your 3 dimensions are. But to solve this, we're going to use the same basics that we did from our last thing, is that we're going to eliminate the same variable from it. So what I'm going to do is kind of try to pick one that I'm in 2 different sets that I'm going to have to multiply things by the least amount of numbers. It really doesn't matter which 2 you pick. For example, I can pick the top and the bottom one, and so maybe I'll do that one in purple, and then I will pick the top and the middle one. Okay, you can pick whichever ones you want. You just can't use the same one twice, or the same pair twice. So in red, I'm going to rewrite x minus 2y plus 3z equals 11, and 4x plus 2y minus 3z equals 4. Okay, I actually, if I just add these ones right now, I can get rid of 2 separate things. My goal is to actually really only try to get rid of 1 variable. So, but if I went to add them right now, okay, what I'm going to have happen is I'm going to have 5x, I'm going to have 0y, 0z equals 15. So then from here, I can solve that. I can divide both sides by 5 and say x equals 3. Great, I already know what x equals. Okay, the other thing that I'm going to do is I'm also going to do some elimination with the ones that I did in purple. So I'm going to rewrite these guys. I have x minus 2y plus 3z equals 11. And then below that, I have 3x plus 3y minus z equals 4. Okay, so the one thing that I've done is just wrote them down. I just had to pick 2 separate sets. I like colors. If you guys don't like colors, I don't know what to tell you then. It's harder for me. And if you are not making sure that you pick different sets, you will have problems. I remember sitting on my bed in high school trying to solve these things because they were just driving me crazy, because I would pick the wrong sets and I wasn't like all pretty and color coded. So color coding is really, really nice. Okay, so I either want to get rid of my y's or my z's because that's what actually got rid of in here. If I only got rid of one, I would have to make sure that I got rid of the same one over here. So what I'm going to do is just, I'm not going to make my addition bar yet because I haven't multiplied by anything, but I'm going to pick z's to get rid of. So, and I like to just kind of write like a little note, some sort of note to make sure that I know what I'm doing, to know what I'm getting rid of. In order to get rid of this bottom equation is going to need a positive 3. Since it's already subtraction, I don't have to do a subtraction sign. But then I'm going to rewrite this equation after I multiply, and I will have 9x plus 9y minus 3z equals 12. Do not forget to multiply both sides of the equal sign. Now I'm going to pretend this middle equation never existed until I go back to check my answer. Okay, not saying that it didn't exist, just I'm ignoring it right now. Okay, then I'm going to add straight up and down. So I will have 10x, and then I will have 7y. I'm adding the top one and this bottom one. 0 z's equals 23. Okay, so now I have these nice two equations, and we can solve those using methods that we did yesterday. So what I'm actually going to do, since I already just have an x equals, I'm going to plug this x in right here. Okay, I didn't need to take up so much room to write that arrow. Okay, so then I'm going to rewrite this and solve for y when I plug an x in. Instead of x, I'm going to write 3 minus 7y equals 23. Okay, I'll get 30 minus 7y equals 23. Subtract 30 from both sides, I'll get 7y equals, or negative 7y equals negative 7. And y equals positive 1 when I divide both sides by negative 7. I'm just kind of running out of room to actually write down my steps. So I know x equals 3, and then I know y equals positive 1. Now I'm going to pick one of my original equations, one of these top 3, and I'm going to plug both of these back in at the same time to solve it for z. Okay, it kind of looks like this top one might be the easiest one. I say that just because it has a single one. If they all have a bunch of gross numbers, by all means, it does not matter whatsoever. You will get the same exact answer no matter what equation you plug it into. Okay, so I'm going to try to do that off to the side over here. I'm going to pick the top equation, so I'm just going to rewrite it for you guys. So I have x minus 2y plus 3z equals 11. I'm going to plug in the x and the y that I know. X is 3 minus 2 times 1 plus 3z equals 11. I'm going to add my like terms right here. I can really kind of just say that this 2 times 1 is 2, so 3 minus 2 is 1 plus 3z equals 11. Before I finish actually doing this problem, I'm going to go correct some stuff that I happen to see, and this happens, and I know it happens, and it always really stinks when it happens, but hopefully you guys noticed already. But I have a negative 2 and a positive 9 will give me positive 7, plus 7, plus 7, plus 7, which will make this a negative 1. So now I'm going to plug in a negative 1, which will make this a positive 2 when I do that. And then it'll be 3 plus 2, which will be 5. Then I'll subtract 5 from both sides, and I'll get 3z equals 6. And when I divide both sides by 3, I will get z equals 2. Okay, I'm going to pick this triple, is what we call this. We used to call them an ordered pair for an xy if we had something like x comma y. Now what we're going to call this was an ordered pair. Now we have an ordered triple. Whoops, I might have forgot a letter. And an ordered triple will look like x, y, z. And this is still a single point, which might mean I go forward x and left y and then up z. Okay, my ordered triple in this case will be 3, -1, comma 2. I'm going to plug this in. I'm going to just pick my point, pick one of the equations. It doesn't really matter which one. If you really wanted to be very thorough, you would pick all 3 of them and do them all separately. We're not probably ever really going to spend that much time doing something, but you need to be able to check. Generally, they have pretty nice answers just so you kind of know that you're doing it right. Um, and I was seeing over here that I wasn't going to get a whole number answer, so I went back and I just went and looked back at my work. So I'm plugging in 3 for my x, so I'm using this bottom equation right here just because it's the one that I can actually see. So I have 3 times 3 plus 3 times -1 minus 2 equals 4. I'm not changing anything from left to right. I'm just seeing if I can get this side equal to 4. So 3 times 3 is 9 minus 3 minus 2. Is that equal to 4? 9 minus 3 is 6 minus 2. That's 4. Congratulations. Looks like we did it right. Okay, so for some reason, if I hadn't noticed that I messed up and I was missing a negative number somewhere, I would have had some weird fraction over here. And you can pretty easily tell that when you only have one fraction, it's probably not going to even itself out nicely. So just do that check in your head. And if you're asking yourself all along, does this seem right? Does this seem reasonable? Then you probably, hopefully, will catch yourself before you get to these gross points. Okay, let's solve another equation, which is going to give us some kind of weird results, and then we'll talk about the different types of results we can expect when we're doing these equations. So I'm just going to do everything in black because I'm liking my color coding. So I have the equation x plus y plus z equals 7. My next equation is 3x minus 2y plus z equals 3. And I have x plus 6y plus 3z equals 25. What your book does now, we can talk about this maybe instead of color coding, is that it numbers all of the equations. So what I would just do is start by just saying this is 1, 2, 3. Whatever you do, do not make these look like it's part of your equation. If that means leaving a space, circling it, putting a dot, putting like a colon next to it, and then just make sure you're always keeping that format for yourself, whatever it is you want that format to be. Okay, every time we get a new equation, we'll give it a new number. So it really doesn't matter which one you're going to do. I think I just kind of always like doing the first and the second together. So if I'm looking at these, it really doesn't matter what you're going to multiply it by, whatever you choose to. Let's get rid of x's. So I have a positive 3 and a positive 1. So what I'm going to do is I'm going to multiply equation 1. So I'm going to circle it, do whatever it, by the number 3, actual 3, so make it look like a 3, not like however you're naming your equation 3. So I have equation 1 by actually -3 so that I can get that subtraction in there as well. So now I will write out this step, so it will be -3 times x plus y plus z equals 7. I'm just going to rewrite this equation, and then I'm also sorry that I can't get all my thoughts together at the same time, and whatever I get from that, I'm going to add that to equation 2. So, and I'm circling 2. So that's what I kind of did over here. But I'm just writing out my steps real fast so that I can keep it in my head. So I have -3x minus 3y minus 3z equals -21. Okay, and then I'm going to add that equation to number 2. So this is equation 2 is 3x minus 2y plus z equals 3. Then I'm going to add things straight up and down. the three x's and the negative and the positive ones add to 0. Then I have negative 5y, making sure I'm paying attention to my sign so I don't mess up again. And then I have a positive or a negative 3 and a positive z, and that will add to negative 2z, and then that will equal negative 18. Okay, this equation here, after I've added them together, I'm going to name this equation. Since I've already done 1, 2, 3, I'm going to name it 4. Okay, make sure I'm circling mine is how I'm keeping track of mine, so I'm going to circle it. Okay, I'm doing this one all in black, so it looks like it's how it will probably look when it's in pencil on your paper. Okay, then I need to get another set of things to add together. So then I want to do 2 and 3. Okay, I'm going to get rid of the same numbers. So I'm also going to have to multiply number 3, equation 3, by negative 3. So just what I'm going to do, I'm going to do equation 3 times negative 3, and I'm going to add that to equation 2. Okay, so then what I'm going to multiply, so I'm going to rewrite that out. So I have negative 3 times x plus 6y plus 3z equals 25. I'm going to multiply everything in there by negative 3. I'll have negative 3x plus minus, 18y minus 9z equals negative 75. Now I'm adding that to equation 2, so I'm writing that below it. So I have 3x minus 2y plus z equals 3. Okay, I add these together. My x's add to 0. 18 and negative 2 will give me negative 20y. Negative 9 and positive 1 will give me negative 8z, and that will be equal to negative 72. Okay, and then I'm going to go ahead and don't forget to name this guy number 5. And then I'm going to solve equation 4 for y. So I'm just making a little note to myself. So solve 4 for y. And that's just to get it into a form that we're used to actually seeing it as. So I have negative 5y minus 2z equals negative 18. I'm going to subtract or add z to both sides. And if I notice, my 2's and my z's would look really, really, really similar if I didn't stick that line through my z. I don't care if you want to make sure that every 2 you make is loopy and you don't do that kind of z, but make sure that you can tell the difference between them at this point. Because we're going to start using z's enough that you need to make sure that they're a 2 or a z or whatever they're supposed to be that you can actually tell. So then I have negative 5y equals, I'm going to write 2z in front, minus 18. Okay, it's the same way. It doesn't really matter what order you put it in. Then I'm going to divide them both by negative 5. Okay, so if we notice this one is really not coming out as nice as that last one did, but that's okay. So then I have 2z divided by negative 5. I'm going to write my numbers in front of the z, so I'm going to have negative 2 over 5z plus, because I had a negative, so negative divided by negative is a plus, 18 over 5. I can't even simplify these fractions, but that's what I have. Then, okay, so then I'm also going to see what I get when I solve equation 5 for y. Maybe then I can set them equal to each other. So solve 5 for y, and I'll get negative 20y minus 8z equals negative 72. I'm going to add 8z over here. Okay, and then I'll have negative 20y equals positive 8z minus 72. Oops, I forgot my 7. Then I'm going to divide everything by negative 20. Divide by negative 20. And then I have y equals 8 divided by 20. I'm going to go ahead and simplify that. So 4 goes into both of them. 4 goes into 8 2 times. 4 goes into 20 5 times. So I have negative 2/5 z. Okay, so if I'm looking at this, so far it's kind of looking like these will be some parallel lines. Let's see if they're the same line or if they're actually going to have different y-intercepts. Not necessarily y-intercepts since they're working in different dimensions than we're used to. But then I have negative 72 divided by negative 20. So we're going to see what everything gets divided by. I'm going to divide everything by 4. 20 divided by 4 is 5. 72 divided by 4, yep, it's going to be 18. Okay, since it's a negative divided by negative, it's a plus. And then I get 18 over 5. Okay, if you guys wanted to see more and you're just like, well, that's kind of odd that I got the same equation, oh well, what I'm going to do is I'm going to do some substitution and I can set them equal to each other. What's actually going to happen, even if I did just set them equal to each other, so I'd have negative 2 over 5z plus 18 over 5z equals negative 2 over 5z equal plus 18 over 5. All that's going to happen at the end is I'm going to get maybe 18 over 5 equals 18 over 5, or z equals z, or 0 equals something. So you could have a few different options of things that you would get when you actually solve this. Maybe z equals z, or 18 over 5. You can get tons of things. It's basically unlimited of what you could actually get. But we have the same thing equals the same thing. What that tells us is we have an unlimited amount of solutions, which instead of unlimited, we call that infinite. Same difference. I can't spell infinite either. Infinite solutions. So it looks really weird and it's still always confusing when I get this for one of my answers. That will actually be what my point is though. So if I were to write this so far as an ordered triple, I haven't solved anything for x yet, but I have y as an equation of z. So this would usually be like my x, y, z stuff. My y will be negative 2 over 5z plus 18 over 5. Okay, and then I still have to find what my x and my z is. And actually, since this is an equation of z, z will just stay z. So whatever you have as an equation, and we can write things in a bunch of different ways, but you will actually have whatever these both are an equation of, you will write it as that. Which I think I just made it sound even more confusing than it actually is. Sorry about that. Since this is as simple as y equals is going to actually get, no matter what equation I solve for, this is what I'm going to get for y. So I'm going to plug this back in to one of the equations and solve for x, because I still need something in terms of x. So what I'm actually going to do is solve, this equation is basically 5. So I'm going to plug this back in for my y right here, because that is one of the simplest ones to solve for x. 3 might not be a bad choice because it just has an x by itself, but then I'd have to multiply everything by 6. So this will be the easiest equation. So I'm going to say plug 5 in into 1, solve for y. Again, I like my color coding a whole lot more, but I'm just showing you some different ways to kind of organize your stuff. So my x, y, z, x plus y plus z equals 7. I'm just rewriting it so that I can scroll down. So now instead of y, I'm going to plug in negative 2/5 z plus 18 over 5. So I have x plus negative 2/5 z plus 18 over 5 plus z equals 7. Okay, I'm going to scroll down a little bit more. I have some like terms to add. I have this negative 2/5 z and this positive 1z. Okay, so when I add that, I'm basically just subtracting 2/5 from 1, and I will get x plus 18 over 5 plus, that will be just positive 3/5 z equals 7. My next step that I'm going to do is get all my whole numbers, or actual numbers, things without variables, so it's not necessarily a whole number, on the other side. So then I have x plus 3/5. I'm actually going to go ahead and add the, or subtract the 3/5 z at the same time, because I just want x by itself, minus 3/5 z. Okay, and then I have x equals, I'm going to put my z in front, so I have negative 3/5 z. That was the only z I had. And then I'm going to do 18, or 7 minus 18 over 5. I'm going to do that in my calculator because really, at this point, I don't like doing much anything. I like saving paper because this stuff takes enough paper by itself. So I'm going to have 7 minus, in parentheses, 18 divided by 5. And it gives me a decimal. Maybe I want to keep everything as a fraction because it seems like everything else is a fraction. What you can do, so I want to re-enter this, so I'm going to do second enter, and I'm going to get my same equation back. And then I'm going to go into math and hit 1 for frac. It will write it as a fraction. I'm going to write it as 17 over 5. I could have done that in my head as well, but I don't like to anymore. Okay, and it's just by chance that those numbers are so close to each other. You could have wrote 3 plus 4, but I just like writing everything in the same terms. So if I have fractions, I like fractions, and if I have decimals, I like writing decimals. So for the rest of my writing out my ordered triple, my x is equal to negative 3 over 5 z plus 17 over 5. Okay, what this means is this is actually my ordered triple, which is very weird to look at. And actually what this represents is that I could plug in any number I wanted to for z. So if I wanted to plug in 5 for a z, I can plug that in and get a solution. So I'm just going to show you what those solutions would look like real fast. So for my x would then equal negative 3 over 5 times 5 plus 17 over 5. Okay, so then x would equal, those guys would multiply to negative 3. So I would have negative 3 plus 17 over 5. I'm just really looking for a number. I'm not worried about fractions and having everything perfect. So then I'm going to change this to a decimal. Doesn't really matter what you do. So I have negative 3 plus, in parentheses, 17 over 5 in parentheses equals, and it gives me 0.4. So x would equal 0.4. Okay, and then I'm going to do the same thing for y. Y equals negative 2/5 z. So I said z was 5 at this point, and plus 18 over 5. I'm going to do that in my calculator real fast. These guys will multiply to negative 2. So I'll have negative 2 plus parentheses 18 divided by 5 in parentheses equals 1.6. So then I would have y equals 1.6. So that would mean that this solution, 0.4, 1.6, comma 5, is just one solution, but there is an infinite amount of solutions that I can pick. And so what that would represent kind of in a picture, which we cannot actually draw these things, there are some really nice programs, maybe if you take some really hard college math classes, but right now we just we don't even have to sketch anything because it's just so crazy. So what this actually represents is that I would have some plane. So this is a really bad picture of a plane. A lot of times you just see like kind of like a parallelogram. And this would be all 3 planes. So no matter what number for z I pick, there's an infinite amount of solutions. These are all the same plane. Because these formulas, when we have this equation in three variables, it's represented, each equation represents the same plane or a different plane. So in this case, they all represent the same equations on the same plane, and there is going to be an infinite amount of solutions. So there's infinite solutions. There will also be, so same planes, you can say they're identical. Um, that's just, this is enough information. What you also might end up with, and this is not the case for this one, is that they maybe all three of your planes, they represent, these equations all represent actual different planes, but they intersect in a line, which is really, really weird to draw, for me anyway. If you want to look in your book, they have a really good picture. Um, so yeah, I'm pretty bad at drawing. That's all I'm figuring out right here. Um, so then I'd have another line coming out here. And they're all intersecting just in one plane, or in one line. So those are kind of weird ones to think about, just not to think about necessarily, but to draw. And you would just have a single line as your answer. And then what is normally happens when we find a solution is, I'm going to try to do a better job of drawing, is that things are only going to intersect in a single point. So you should probably look on your book on page 497. And actually, I think I'm doing a really awesome job at drawing this one. Yeah, I'm pretty bad at drawing. That's all I'm figuring out. Okay, so it's really weird. Okay, a better thing would have been to just kind of Google some pictures of what's actually happening. Let me look up some pictures. Okay, so these are the types of intersections you can have. Sorry that I tried to draw something for you. Okay, so this top left one is what's going to happen when there's no intersections whatsoever. That would mean that I have three parallel planes and there's no solutions. Okay, this bottom one here also has no solutions, even though the one plane crosses the things twice, crosses the two different planes, because not all three of them meet at any one single point, so there's no solutions. Okay, this next one over here where it kind of has a triangle also has the same type of thing where they don't actually intersect all at the same point, so there's no solutions again. The points that the two separately intersect at, these lines that they make when they intersect never actually cross. Okay, this top one is what I was trying to say when I have the infinite amount of solutions formed from a line. They all cross at the same actual line. And so if you wanted to make like a little note right here saying line. And this one down here would be like the corner of a room. What's happening is if you look up at any corner in your room, you have three planes intersecting in a corner. And a corner is considered a single point. And what that's going to look like when I actually have some solutions is it will look like this XYZ equals that we got on our first problem that we did. And then the next problem that we did, we got this stuff, and the thing didn't actually show the first example that I kind of made that was having three same planes sitting on top of each other. And you have the same equation for all of them. Okay, real fast, I will just go through setting up an equation for you guys. We won't solve it because I think you guys should be able to solve them now. Okay, so the question here says Luis inherited $15,000 and invested part of it in a money market account, part in municipal bonds. So we're going to say money market, municipal bonds, and a mutual fund. Okay, I just like giving things initials so that I can pick my variables accordingly. After 1 year, he received $730 in simple interest from the three accounts separately, so from all three. Okay, that's important that they said from all three. The money market account paid 4% annually. The bonds paid 5%, and the mutual fund paid 6%. There was 2,000 more invested in the mutual funds than in bonds. 2,000 more in mutual funds than mutual or than whatever B was than bonds. Okay, find the amount that he invested in each category. So since we have three variables, that means that we need three equations. If we do not have three equations, then we cannot solve anything. Okay, so if you can only write two equations and you have three variables, you can't do anything. So that would suck. So what we're going to do is I'm going to call these just M, B, and F for money market, mutual bond, municipal bonds, and mutual funds. Why did I not write an F? Okay. My total amount that I invested, so all three together, was 15,000. That will be M plus B plus F equals 15,000. Okay, I really like just writing down everything that you know. Okay, 4% came from this guy, 5% came from that guy, and 6% came from that guy. When you guys are reading these sentences, what's going to happen is that you will actually have, basically, they break up sentences so that each sentence you can make a different equation from this. So 4% is really as a decimal point 0.04, 5 is 0.05, and 6 is 0.06. So I earned $730 from those three things. Okay, but I can't just say 0.4 plus 0.5 plus 0.6 equals 730 because it doesn't. But the amount when I multiply it by my variables gives me 730. So I have 0.04 M plus 0.05 B plus 0.06 F. And that amount equaled $730. And then I also have an equation, so I earned 2,000 more. So more means addition. I earned 2,000 more in mutual funds than in bonds. Okay, so my bonds is equal to the amount that I had in my mutual funds plus 2,000. Okay, those are my three equations. My first step, since I have one letter equals something else, my first step would be to just start plugging those into both equations. And then you can plug them into both equations, and these two equations will then only have an M and an F in them. And then you can solve them like a system with just two variables. Okay, we use three variables more than anything else. But there are some of them that have four variables in there. Those happen not necessarily when we're working in up, down, left, right kind of dimensions. It's more of actual finding the amount that we sold of this, this, and this. But I want you guys to do numbers on page 500. They're like $4.99 really, but 500's easier. And I want you guys to do 1 through 9 odds, number 15, and then just do 15 through 36 by 3s.